This video is going to look at how to calculate the probabilities of both type 1 and type 2 errors, specifically for a lower tail normal distribution hypothesis test, so a z-test or a t-test, using a TI Nspire calculator. Just a quick review that a type 1 error is when you reject the null hypothesis when it's true, and that means that your sample value fell into the critical region even though H null is true. A type 2 error is when you keep the null hypothesis even though it's false, and that's because your sample value fell into the keep region even though the null hypothesis is not true. So starting with in this video just a normal distribution, meaning that you're using either a z-test or a t-test, you want to first keep in mind that you are going to be using the sampling distribution. And so I should say sampling distribution. So you have the mean is the population mean, and your standard deviation is, your variance is actually your population variance assumed divided by n. So we'll have to keep that in mind, particularly for the type 2 errors. So the probability of a type 1 error is simply alpha for your anything that's using the sampling distribution, the normal distribution. And that is because type 1 error is the probability that your sample fell in the critical region even though, or given that so that you reject, let me just mark that down, you end up rejecting H null even though your mean equals the hypothesis, which means you should have actually kept it. Well, the definition of this actually, under this condition, the p-value of your sample following in the critical region is 10%, is your alpha, is your level of significance, which might be 10%, 5%, 1%, 0.1%, any of those. And so that should be the easiest question for you to answer. Type 2 errors are a little more complicated, and since this is for IB math, I'm not going to talk about the more advanced ways of calculating type 2 errors. For example, if you know the statistical power of your study. We are simply going to look at if you actually know for some reason what the true mean is. It's not equal to the null hypothesis claim. So we're calculating the probability that your sample falls in the acceptance region, and the problem will have to give you the true mean. So let's say the problem tells you the true mean is 10. So when we do the normal CDF calculation, we're going to enter 10 here, and we're going to use the same standard deviation as the sampling distribution. So that would be your population standard deviation over the square root of n. And then your probability of falling in the acceptance region, well, like let's say your critical value was 7 and you're doing a lower tail test. You would set it up like that. If you're doing an upper tail test, you'd have some really big upper bound, and your upper value might be, I don't know, 17, so you would calculate depending on what your tail is. And so let's do a couple problems here, taking a look at how to actually apply that. You've planted 30 tulips and suspect the brand you've purchased has a stunted height. As an experienced gardener, you know that tulip heights are normally distributed with a mean height, that's the population, and that's also the claim, of 17 centimeters, and a standard deviation of 1.2. So that's your population standard deviation. Let x be the height of tulips in centimeters. Let's say that you are doing your test at a level of significance of 10%, so alpha is 10%. The sample size is 30 tulips. That's what you're measuring in your garden. Null hypothesis is that mu equals 17 centimeters, and the alternate is that mu is less than. And that's because you're concerned about stunted height. This is a lower tail test, which we need to think about for the probability of a type 2 error. Part A, find the probability of a type 1 error. So this is the probability that your sample for your 30 tulips falls into the critical region, even though causing you to reject H null, even though H null is true. And so the definition of that is alpha, which is 10% for this particular problem. Part B, unbeknownst to you, the true value of the tulip brand height is actually 16 centimeters. So you are right, but you didn't know it maybe. Find the probability of a type 2 error. The first thing we want to do, since we're going to be finding the probability that your sample falls in the acceptance region, we need, in order to know what the acceptance region is, we need to figure out the critical region and therefore the critical value. We'll use inverse normal on the calculator, and keep in mind that the TI Nspire reads from left to right. So reading in this direction, we're looking for a lower tail test. This area is going to be 10%, and we want to know what this critical value is so we can get the critical region. So you're going to enter into the calculator the percentage, the area as a decimal, 0.10, mean will be 17, and the standard deviation will be the sampling standard deviation, 1.2 over square root of n. So that's 1.2 over root 30. This is what it will look like in your calculator, and I'll show you how to do that in a moment. But the critical value ends up coming out to being x equals 16.7 centimeters approximately, which means your critical region is x is less than 16.7 centimeters. That's your critical region for a lower tail. That means the acceptance region is x greater than or equal to 16.7 centimeters. So for the acceptance region on this side, we're going to be using that in our probability of a type 2 error. So probability that x fell in the acceptance region given something that is not the null hypothesis. So acceptance region meant your lower bound is going to be 16.7, and then we're going up from there because this whole region is the accept region. And you can enter in anything really big. You know, if you had tulips that were 999 centimeters tall, that would be absolutely massive. So just any big number. Your mean is 16. Your mu, use the same, sigma, use the same sigma, 1.2 over root n. When you type that into the TI Nspire, it will look like this, and that probability comes out to being quite small, less than 1%. It's 0.0514%. So the probability of a type 1 error, type 2 error in this case, is actually smaller than the probability of a type 1 error. Now just a quick note, if you want to make the probability of a type 1 error smaller, you simply reduce your level of significance. You make alpha smaller, and that will make the probability of a type 1 error smaller. If you want to make the probability of your type 2 error smaller, you need a larger sample size, a larger n. Okay? So let's take a look and see how to do this on the TI Nspire. So the first thing we're going to do is open up a calculator scratchpad or calculator document. I'm going to clear that because it's all wrong. And we're going to start with inverse normal because we want to find the critical region so that we can find the acceptance region. So probability or stats, and then choose distributions, which is number 5 in both of them. We're going to go inverse normal because we're finding a value on the x-axis. The area under the curve for a lower tail test is going to be your alpha. Lower tail test it's going to be the calculator reads left to right on the distribution. But if you're doing an upper tail test and your alpha is 10%, you'd want to enter 90 because the calculator reads left to right. We have a lower tail test, so we're going to put 0.10 for 10%. Mu is the claimed height, or what you believe, what you know as a gardener for the tulip heights is 17 centimeters tall. The standard deviation, since we're using the sampling standard deviation, we're going to type in the population standard deviation of tulips, 1.2, divided by the square root of your sample size. And that is the standard deviation of the sampling distribution. This is not the standard deviation of the population of tulips. It's for your sampling distribution. If you were to get a whole bunch of samples of tulips, they would be distributed following this model. And there is our critical value, so a height of 16.7. Anything lower than this, because we have a lower tail test, would cause you to reject your null hypothesis. Well, anything bigger than this would cause you to accept your null hypothesis. So what we're going to calculate next is a normal CDF where your sample falls in the acceptance region. So this number or bigger, okay? Given that the mu is actually not 17, but 16. So I'm going to use my trackpad and highlight this. I'm going to go Control C so I can copy that value because I don't want to use a rounded value in my next calculation. Menu, probability or stats, and choose number 5, distributions. We're going to go normal CDF. So we want anything from 16.7, so Control V, or bigger. So what would be a really, really big tulip? Just type in some giant number. That would be a huge tulip. And now in this mu, for the mean, we're going to enter what the problem gave us, the true mean of that brand of tulips, which are a little shorter than what occurs naturally. So 16 centimeters. And we're still assuming that the brands, this tulip brand is following the same standard deviation. So we'll enter 1.2 divided by the square root of your sample size, the 30 tulips you planted. And there is the probability of a type 2 error.